take a look at the next 5 questions from the SAT math subject test. So here I've got question number 11. So let's take a look. The graph of x squared minus 1 times y equals x squared minus 4 has the following qualities, and we have to find out which one of them is correct. So for problems like these, I always have white paper so I can kind of visualize what the problem is saying. So first things first, I want to visualize what this graph even looks like. So x squared minus 1 times y is equal to x squared minus 4. Now I immediately notice some things here. First and foremost, I have to solve for y, right? Because since this is a single variable function, I should always try to express whatever quantities I have in terms of y, the independent variable, or the dependent variable rather. So I'm going to have x squared minus 4 on the top and x squared minus 1 on the bottom. Now, I made a second observation, and that's the fact that here I have 2 difference of perfect squares. So I can break this down into x minus 2 times x plus 2 over x minus 1 over x plus 1. Now here's where things get a bit tricky. Vertical asymptotes occur when the denominator is undefined, or in other words, 0. So when is this denominator undefined? Well, check it out. This denominator right here is gonna be undefined when my x value is either 1 or negative 1. So when x is equal to 1 or negative 1, I'm gonna have a vertical asymptote. Okay, so let's see which one of the 5 choices has that quality, that x equals minus 1 and 1 is a vertical asymptote. So let me go ahead and check out the choices. So one horizontal and one vertical asymptote. Well, I already know I have 2 vertical asymptotes. So let's see which one of them says that. One vertical asymptote, wrong. 2 vertical but no horizontal asymptotes. 1 horizontal and 2 vertical asymptotes. 2 horizontal and 2 vertical asymptotes. Neither a horizontal nor a vertical asymptote. Okay, so we're left to 3 choices. Now, all 3 choices say that we have 2 vertical asymptotes, but they vary in how many horizontal asymptotes we have, either 0, 1, or 2. Now here's the problem. I don't know how to find horizontal asymptotes, but I'll wager a guess. Now, in calculus, remember that a horizontal asymptote occurs when a function approaches some singular x value as it tends to infinity. So let me show you what I mean. Let's say we have a function like this, right? This is a pretty famous function. Hopefully you know which one this is. And this function has some kind of a horizontal asymptote, like that, right? And remember, horizontal asymptotes can indeed be crossed by a function, unlike a vertical one. Now, here's the fact of the matter. The fact of the matter here is that the function has a horizontal asymptote here at whatever x value this is. Let's say this is x equals some value a. So how can we actually find what horizontal asymptote this is? Well, observe that this function, as we take its limit as x approaches to infinity of this function, we should get this horizontal asymptote, right? So even if you don't know calculus, hopefully you can take this approach and apply it to this SAT math problem. So usually the SAT doesn't have calculus, but calculus can help you here and there if you forget algebra, which I do, which is kind of sad, but that's okay. So let's go ahead and try this out using this new calculus-based tactic. So let's go back to our function, and our function is I know that you can't see it, but let me go ahead and write it down. Here's our function, x minus 2 times x plus 2 over x minus 1 over x plus 1. Okay, and now we want to take the limit of this function as it tends, or at least as the x value tends to infinity. So the limit as x approaches infinity of x minus 2 times x plus 2 and x minus 1 times x plus 1. Okay. So how do we take this limit? Well, when you take limits like this, it's important to observe what happens to the function as your x value becomes incredibly large. So imagine my x was something like 1 billion. If I plugged in 1 billion here, this minus 2 wouldn't matter. None of this would matter, and as a matter of fact, I just end up with 1, right? Another way you could probably think of it is if I were to distribute everything out, I'll be left with x squared minus 4 over x squared minus 1. But if my x is incredibly large, these minus 4 and minus 1s don't matter. And since my degree at the numerator and denominator is the same, I know my limit is just going to be 1. Meaning I have one single horizontal asymptote at x equals 1. And so that means my final answer is going to be 2 vertical and 1 horizontal asymptotes, which is choice C. Oh, wow, I thought the SAT doesn't have calculus, but the next problem is actually calculus, which is funny. Okay, so let's look at the next problem. The limit of this as x approaches infinity. So usually these kinds of problems can be factored, otherwise you can just use the quadratic equation straight out. But since we're taking limits here, it's important to just look at the highest degree terms. So only pay attention to the highest degree term on the numerator, which is 3x squared, and the highest degree term on the denominator, which is 6x squared. And that's, of course, simply going to be half. Alright, folks, and that's choice C. Alright, this test seems to be not too bad, but the only problem is I don't know where I can find the next question. Oh, I found it. Okay, question 13. Okay, question 13 asks me the following question. A linear function has an x-intercept of square root of 3 and a y-intercept of square root of 5. The graph of the function has a slope of... Okay, well, we know the x-intercept, so let's go ahead and write it down. That's going to be square root of 3. And we know the y-intercept. It's going to be square root of 5. And now we just have to find what slope this function has. And since it's linear, all we have to do is y2 minus y1 over x2 minus x1. So from calculus to literally pre-algebra. That's how we're going. Okay, so that being said, let's go ahead and do that. I know that one of the points on this graph is going to be square root of 3 comma 0, and the other point is going to be 0 comma square root of 5, right? Because that's the x-intercept, and here's the y-intercept. And so that means my slope, or my n, is simply going to be the difference of those two. Square root of 5 minus 0 over 0 minus square root of 3, which gives me square root of 5 over minus square root of 3. And what is that? Well, obviously you can't do that by hand, so I'm assuming we have to use a calculator. So square root of 5 over square root of 3 is going to give me approximately negative 1.29. Alright folks, let's see which one of the answer choices is negative 1.29. That's going to be choice A. Alright, we're almost there. Question 4. Question 14. If f of x equals 2x minus 1, find the value of x that makes f of x equal to 9. Okay, so first of all, we have to find what the function f of x is. So since we already know f of x, we can find what f of x is. So f of x is simply going to be 2, and instead of 2x minus 1, I'm simply going to plug that value in for x. Okay? And of course, I'm going to set this equal to 9 because I want to find the value of x that makes this equal to 9. So I'm going to have 4x minus 2 minus 1 equals 9, and so I'll have 4x minus 3 is equal to 9. That means 4x is equal to 12, and so we have x is equal to 3, folks. So that means our final answer choice is going to be B. Let's go ahead and take a look at question 15, which is the last question for this video. The plane 2x plus 3y minus 4z equals 5. Now we're into vector calculus somehow. Intersects the x-axis at this point, the y-axis at this point, and the z-axis at that point. The value of a plus b plus c is, well, to answer this question, we actually have to find what the x, y, and z-intercept for this function is. And in this case, it's pretty easy. So, let me grab a piece or a sheet of white paper, and let's get started. So, let me go ahead and write down, what our actual function is. Let me prop it up right there. So we're gonna have for question 15, we have the following function: 2x plus 3y minus 4z equals 5. And note that this is a multivariable function, and we have to actually find the exact coordinates of its intercepts. So let's check it out using some colored markers. One color for the x, one color for the y, one color for the z intercepts. So let's check it out. So for my x-intercept, I'll use green, sure, why not? So X Intercept. So to find the X Intercept, I'm going to have to set Y and Z to 0, right? So for X Intercept, Y equals 0, Z equals 0. It's almost like an electromagnetic charge in a vacuum. Your rho and your J, your charge density and your current density are both going to be 0. If you have no idea what I'm talking about, go ahead and check out our physics lectures. Okay, so I'm just going to have 2x is equal to 5, meaning that x is equal to 5 over 2, which is basically 2.5. Now, what about our y-intercept? Well, our y-intercept, we're going to have to do basically the same approach, right? We have to set x to 0 and z to 0. So if I set those two values to 0, I'm going to get 3y is equal to 5. That means y is equal to 5 over 3. And 5 over 3 is what? Let me check. 5 over 3 is equal to 1.6. 1.6 hat. And finally, my last calculation for the intercept is going to be the z-intercept. What's my z-intercept? Well, then I'm going to have to set my y to 0 and my x to 0. Just like I did for the other ones, almost. So I'm going to be left with minus 4z is equal to 5, and so y, or rather in this case z, is equal to 5 over negative 4, which is minus 1.25. Now what I have to do is add up all of these values, all of these intercepts, right? So if you look back at the problem, we have to find the sum of all of these intercepts. So let's see. We have to find 2.5 plus 1.6 plus minus 1.25. So think about that. Think about that. Let me bring in my second sheet of paper. So I'm going to have my x-intercept, which is, oops, all of my stuff is falling down. My x-intercept is going to be 2.5. So let's put that down right here. So my x-intercept is going to be 2.5. My y-intercept is going to be 1.6. And my z-intercept is going to be minus 1.25. So 2.5 minus 1.25, that'll leave me with 1.25 plus 1.6, which comes down to approximately 2.85. All right, folks? And that should be the answer to number 15. Hopefully that's in that range. And I've been fooled. I have to express my answer as a fraction, not as a decimal. So let's see how we can do that. So I'm basically adding up 5 over 2 plus what was it? 5 over 2 plus 5 over 3 minus 5 over 4. So let's go ahead and express this. That's going to be 10 over 4 plus 5 over 3 minus 5 over 4. So that's going to be 5 over 4 plus 5 over 3 is equal to, what is that? That's going to be 12, 15, and 12, and 20. So my final answer is going to be 35 over 12, folks. And what choice is that? I'm sure you can already see it. That's going to be answer choice B. Contrary to popular opinion, it is not choice C. Alright folks, so thanks for watching, and we'll check you out next time.